Hello, everyone. Good morning, good afternoon, and good evening. For me, here it is afternoon, and good thing is the spring has started and the temperatures are nice in Germany. And before I start, so I have two monitors, so I'll be in between. I might be looking at my second second screen. So hi, I am Dr. Johnson. Share my screen. Yes, I'm Dr. Johnson. I'll be talking about SkyPro Guide plan software. And before this, we have done four modules from implant planning to matching and segmentations, nerve detection, CPR, and also double scan techniques. We have done all these in four modules. Today is one of the most important module where we will be talking about different varieties of surgical guide designs possible in SkyPro Guide software. So I hope you're able to see my screen. So today what we'll be seeing is what we'll be learning together is regular surgical guide designs, stackable guide both on soft tissue and bone supported guide, and also double scan guide. How do we manage to make a guide out of the denture, and also orientation guide. So before going to this, what we have done to reach the stage of surgical guide design. So we have imported files and then we match the files, followed by we do auto CPR and nerve detection, and then we do implant planning, and then we go for surgical guide design. All these steps we have already learned in our previous session, previous modules. So now I'll directly jump into surgical guide design. Here is my software, SkyPro Guide, and I will open my case. So as I said, plan planning is done here, and then I will go directly to guide design. So this is guide designing option. So first I click on this, and here I have to select. I can see here which model, which of the models I need to make guide on. So which STL file I should select. So I select the anatomy file because I'll be making guide on top of this. Then I select the path of insertion, how I want the guide to go into the patient's mouth. And once I select the orientation, I click on this option, set insertion direction. I click on this. So this is the path of insertion. Then I can create a space between the guide and the model. Here I can increase or decrease the amount of space I want in the guide. So these are few parameters which we can adjust and learn according to the 3D printer which we are using or milling technique what we are using. So right now I'll use zero point 0.3 microns, and then I say generate undercut. So once the undercut is blocked, you can see here the undercuts are blocked. You can, if you think, for example, this area you want to block a little more undercut, you have always freeform tools here. You can click the freeform tool, reduce the size of freeform tool, and then you can add some some extra material to block. And once you have done this, and if you want to understand the difference between your original model and the blockout model, you can say here show color difference, and the red or pink the area, the more blocked out those areas are. This area is more blocked out, so you can understand the difference here. So once my undercut STL file is ready, I go to the next step. Here I have three implants. So I will show two variations of surgical guide on the same case. The first variation is all these implants are green color marked, means they are selected for guide design. So I come here and I start clicking the margin of my surgical guide. I click where I want to give the turns. So I'm not clicking short distance. I'm clicking at a distance. I'm giving some long distance. So wherever I want to, I feel like I have to give the curve, I click on that area. And then at the edge, I join them here. If I want to add one more point, I can click on that and just drag it. And then we can do whatever corrections we need to do here. So here again, there is guide offset. So this guide offset is again the gap between the undercut model and the guide. So in previous step, we had given zero point 0.3 mm of space or zero point 0.3 microns of space. Here it is zero point 0.5 micron space. So total it comes to zero point 0.8 micron of space between your original STL file and the guide. And then we have parameters like occlusal and perimeter thickness. So this is the thickness of the overall guide, which I normally keep at 2.50 or something like that, which is sufficient for me. And these are support around the sleeve, which you will see as a sleeve and support around them. These default settings are working good for me. This again, you have to check according to the 3D printer technique you're using and what kind of resin you're using, all that depends. And then I can say create guide. So once this guide is ready, I can use freeform tool to polish the surface or smooth the surface. Entire surface. So whatever changes I want to do, I should be doing it at this stage to the guide. If I want to add it here, and then we have tools for making window. So I can make a window like this, or I can reduce the size of the window and just make a window, smaller window. I can reduce the height of the window and I can make short small windows here. So how you want to visibility in patient's mouth. Of course, we cannot do window here because you cannot see anything. So you can make a window here and how you want to see. And then we can also add the patient's names like student. And I can add the name here and increase the size. I can add the name here. If all these options are okay for you, then we go to next. Here your guide is ready along with the sleeves. But in some situations, like we don't want to give such a U-shaped guide because these are on the opposing sides. I want two individual guides. So what I can do is I go to guide design. I will create a new guide. These steps are same. I want to create undercut. For example, right now I'll create a guide on this side. So I will look for path of insertion for this surface. And then I say insert direction and then generate undercut. And I go to next step. Now I want to make guide only on this surface, not on this side. So what I do is I click on 4.6 and 4.7 and deselect them. Once I deselect them, that means only this is active and I can make a guide only on top of this. So I mark my margin and then they say create guide. So only this side the guide is created. We can smooth it. Go to next step. The guide is ready for your printing on this side. Similarly, we can go to create new guide again. And this time we want to make guide on this side. So I try to visualize from straight path of insertion from this side. And I set new direction here, generate undercut again. And then I go to next step. Now this side, I switch off 3 6 and have 4 6 and 4 7. Now I start selecting the margins. Okay. And then I say create guide. And this side guide is created. Then smooth the surface. If you don't want these gaps, you can always add material. You find some errors like this, you can smooth this surface. You can give a round window here. Like this. And once we are done, then go to next step. We have a guide here ready. So this is how a simple guide can be created. Now we will go to little complex sides. So now I will exit this particular case. I will show some other case. So I'll exit this. It is asking me if I want to save the project. I can click on yes, save the project. I can give a new name for this, like guide designed. Okay. So have a new project. The old project file is this, and have additional new project file. If I want to share the complete file with somebody, I can click here on share patient. But if I want to share only implant planning, I can upload here. And if I want to share implant planning and guide designed already, which I've designed, I can click on this. So that's how you can share the files or save multiple or files on multiple stages. So next is, so we have learned how to do a surgical guide design. Now next step is stackable guide design. So here you have to listen more carefully. The steps feel little complex, but once you start practicing at least or 3 or 4 designs you make it, it will be very easy for you to remember and understand. So I expect little more concentration when I'm going through this procedure. In the beginning, it might look complex, but it's not so complex. So as usual, we import files, match them, do CPR and nerve detection. And the next is sometimes because it's stackable guide, we want to do soft tissue guide on the gingiva, then we have to do some virtual extractions. If you are doing bone reduction guide or bone supported guide, we need to do segmentation of the bone, which we have done in previous module. The fourth module is all about bone segmentation. If you have not didn't attend the segmentation module, it'll be there on YouTube. You can check that. Even virtual extraction I have explained in module 2. You can see that module 2. And then after these procedure, we do implant planning and start designing stackable guide. So I will go to stackable guide, soft tissue guide first. Open the case. So here is my case. So first I'll explain you what are the objects in this. I will switch off all things. Yeah, so now we have a case here. Okay, so we have a patient who comes with number of teeth, partially dentulous. We have a patient like this. Now the request is to do complete extraction followed by all on 4, all on 6. For Brilliant is fast and fix or unicorn. We have to extract all of them and then followed by do a stackable guided surgery. So virtually what we do is we have this model like this. We extract these remaining teeth virtually and we have a file like this. So first step is to do virtual extraction, and then we plan our implants and also we plan our pins. All this is explained in previous module, how to do all on 4 or all on plus cases. So we do this planning. Once this planning is done, the next step is to, we also have designed processes for this. So if you see, this process is directly on the unicorn abutments. So now we have all the STLs file ready, the partial dentulous, the edentulous jaw, and the final process. Now we have to design a stackable guide for this particular case. So how do we do it? So the first step, as usual, we go to guide design. So in the guide design, first we have to design a guide for base guide and tooth supported guide, which is not on this model, but it's on the partial edentulous model. So I select the partial edentulous model, that is this model. I need to make my first guide on this because the patient still has these teeth in his mouth. So I do a same procedure. I do I check from the occlusal surface for path of insertion. Then I click on this. And now let's create undercut blockout. So now I have blocked out model and I go next. Here, first important thing is I'm making a guide for tooth supported on the partial edentulous jaw. So I'm not making a surgical guide, I'm making a base guide first. So I switch off, I deselect these implants, 6 implants, but I am keeping the pins active. So in the first guides, pins will be active. So where are the pins? Here are the pins, pin B, pin D, pin E. So I click on pin. I see where are the pins. Now my guide should involve this pins, the first guide. If it's little confusing, at the end of the entire guide design, you will understand what is happening. So I start the margins. So I click on this area. Okay, I'm just cross-checking whether I've involved the pins. I would like to take this little deeper. Okay, so this looks fine. And now I create guide. I use smooth tool to smooth the entire surface. I mean, you need not even smooth if you are comfortable with this particular design. So once the smoothing is done, I say next step. So my partial stackable the first step is done. Now what I have to do is I have to cut this guide into two parts. One is base guide and one is two supported guide. So how do I cut this into two parts is I go to sandbox here. This indication is sandbox. I click on this, and here is an option called volume splitting. So the meaning itself is splitting into two. So I click on this. I have my guide and I need to split the guide. I have to make a slot for this to cut. Click here. I am making points at a distance. So there is one more option. If I extend the guide beyond this teeth, I can do extraction of this teeth, or if I want to do extraction later, but I want to keep the guide as on this support, I can keep it like this. So if you want to even extract this right now, I think it's better to extract because implant is here. So I will just go back. I will show both, this without extraction, this with extraction. So you can cover both. Next step. This we have already done, so I'm just quickly going. I click on volume splitting. I see from the occlusal surface. I click on add slot. Then outside the surgical guide, I click some points. And then I say apply. So it has created a plane for me. So this plane is very important in the next steps. So I have to adjust this plane. I can use what is this shift and click on the plane and adjust the plane. I have to drag it down, just the plane a little more. So this plane is the cutting surface. Below this is one guide, above this will be another guide. So the below this will be the base guide. Now I have to cover this surface. So I press on control and pull it up. I can pull it little up. So I see from all the sides. And then I press shift and click on it again so that this orientation, this thing goes off. You can see these things are not getting cut, but how to remove that, I will show it later. And also if you press control and click on this, the points which you created before can be reused again if you want to extend something like this. Or you can create new points also. So if you think this is fine, just this step will take some time for you to understand when and where am I cutting. We will do some mistakes and then we will rectify it again repeat some mistakes, but in time you will understand it. Even now I tend to do some mistakes, but then I know how to rectify them. For example, see this part is getting cut. I don't want that to happen. So I move it little up. Then if you're happy, then go to next. And here we have subtract all slots and subtract selected slots. What happens is sometimes if our other models like this model is also present in this, and if we click subtract all, then it will divide even the STL files and surgical guide, everything, whatever is visible. So normally I switch off everything, and since this is selected, I just say subtract selected slot. I say subtract, then if you see this slot is cut into two. Now I go to end tool. Now I have a base guide. Now I'm not totally convinced with this base guide. So what I do is I see it from the top and go to edit object and then remove, select, click area, and then select these surfaces which I want to remove. And I say cut and area and cut area, cut. So this is one way of cutting things. But again, when this base guide is on the patient's mouth like this fixed, and you have to place your final processes. Just to show, I will switch off the STL file. You can see there is a hindrance of when I place my process, it can touch the surgical guide, and we may not be able to place it properly. The processes, final processes. So there is one more option for this. I can go to end tool. I have to end the edit tool. Now there is option called Boolean operations. I click on Boolean operations, and from object A to object B, I want to subtract. I click on subtract. That means this surface, whatever surface is touching, I want to subtract from the surgical guide. And I can increase little offset so that there is a space between this and this. And then I say, keep observing this place, this area. I say apply. So whatever surfaces were touching the teeth is all subtracted, plus extra space of 30 microns. So that's how your base guide is ready. If you want to do any more object adding or something, you can always go to edit and add substance if you want, if you think you should add substance. This is the base guide which is ready, and you have a tooth supported guide. So finalize it. So you have split the guide into two parts, the base guide and the tooth supported guide. The next option left is we have to make a surgical guide for with which you need to place the surgical implants. So we go again, create guide, create a new guide. This time we want to imagine now we have extracted all the teeth, and this time we want to place a surgical guide, and then we need to place implants. So we select edentulous jaw. So we have done complete extraction, and then we click the path of insertion, and then generate undercut, that is blocking out of the cast. Go to next step. Now we have to involve these implants, but we don't want to involve the pins because pins have been involved in the base guide. So now we have this. I have to select, I have to cover all the implants. If you think it's fine, then we just click create guide. So now we have guide. We just smooth the surface and then go to next step. So here are your different stages. So this is your surgical guide ready. Now I'll explain you step by step. So this is how our patient walks in. Okay. Now what we do is we place base guide along with tooth supported guide. I will change the color of the base guide. Change color. Here I have option. If you see these three lines, I click on this, change color just so that it's easy for us to understand. I will keep maybe blue. Yeah. So blue is the base guide and this pink is the tooth supported guide. So what we do is we place these on this particular patient. Once he arrives, we place the base guide and the tooth supported guide, and then we drill the pins into this. And once this base guide is stabilized, we remove the tooth supported guide and we do extraction of these teeth. Once the extraction is done, we have cast like this, the patient's mouth is like this, and now we place surgical guide, and on using this surgical guide we place implants. This is the procedure. But right now if you see, I am not able to place my surgical guide on top of this base guide because of the interference, right? So what I have to do is, as usual, again we have to go to sandbox. So in sandbox we will be doing volume splitting again. In this volume splitting, our slot is already there. We are not supposed to touch the slot at any point. This cannot be activated. This circle cannot be activated. At the maximum you can do is this one, and you can adjust the posterior points if you want, little bit here and there, but you should not touch this base surface because this is how exactly it will cut off. So now I will go to my slot is ready. I'll go to next step and I say subtract the selected slot. Now the slot is cut. I go to end tool. I have guide cut into two parts. I finalize it. So I have a surgical guide with this color. I will change of this surgical guide to maybe this color is okay. And this part is of no use for me. So I need only this one. So this part which was impinging my base guide, I will delete it. I don't need this. Okay, so now I have this and then I have a base guide. If you see now, my surgical guide is properly sitting on the base guide. Is it? I hope this is very much clear. So now, how is the procedure? After extraction, my base guide is still stable with the pins. Then I place my surgical guide. Then I place my implants. Then I remove my surgical guide. I remove the pins. Then I remove, then, no, I don't remove the pins here, sorry. Pins are here, I remove the surgical guide. Now I place my final prosthesis with the help of the base guide. I will show how to take support. And then once my prosthesis is ready, I remove the pins and then I remove the base guide. Where is base guide, yeah. I remove the base guide. Patient walks out with the complete prosthesis. This is the procedure. Now, how do we stabilize each guide with one another and also processes. So again, here we have to go to sandbox. We have something called connectors, add connectors. Okay, so this is my surgical guide, and where is my base guide? So these two are my guides. I need to connect them using a lock and key. So I click on add. I have different varieties of connector designs here. I would prefer this one, and I say OK, and I click on this surface. Rotate it, and I also reduce the size of my connector. This was too huge, and I need to check. So this lower one is female and the upper one is the male. Now my axis has to be correct. The path of insertion should be in Z axis should be straight. So I just try to see from the top as parallel as possible. And then I say from view. So this becomes parallel. If I'm okay with this particular placement, this has to be in one and the other has to be in the other guide. If I'm happy with this position has to stay like this, the Z axis. That means this has to go into this, and I have to add more connectors. So all the connectors should have path of insertion be parallel to each other. So I just say this is a duplicate. I just add here duplicate, and I tilt this. I'm not touching this red and rotating the Z axis at all. I'm just positioning this. Similarly, I can have one on the lingual side. Depends on how much mouth opening and tongue movements, whether it is and what kind of anesthesia, GA or local. So I add 3 connectors. I'm happy. I say next step. So right now I'm joining the base guide with the surgical guide. I have 2 more things to join. So I go to next step, and here this is the base object. That is base guide is always steady, and these are removable. So I just apply. So if you see these have joined together. Now this is one STL and this is another STL. Same thing I need to change and apply on other surgical guide, that is tooth supported guide. So this is tooth supported guide. I click apply on this. So the position of the connectors remains same in all the guides. Okay. Now this is a little tricky. Final processes also can be connected to the guide, but it's little tricky because the guide handles don't reach till here. So I will show how to do that also. Okay, so we have an additional step here to connect these two. So I will end this here, and then I'll come back again to how to do connect this one. So now my base guide has a female, and then my tooth supported guide has male. So these have to be parallel to each other, and then this is my surgical guide. This is how stackable guide is made. Most of you will be practicing this. Prosthetics also on the stackable guide is rare to practice, but I will show you how to do that. So I have here something called geometric primitives. I click on this and I say add, and I have some cylinder here. I click on cylinder. This is too huge. I can reduce it. I've to bring them to the position of the connectors. How to play with this tool, also I have taken webinar on this topic also in my previous presentations. So I'll just switch on some other connector and make it transparent. I will try to orient it. This seems okay to me. And then similar fashion, I duplicate this same measurement and I try to place it here. These are additional features which we may not use also most of the practices, but yeah, you should know. Now it should touch. I'm using control key to pull it only this surface. If you don't press control and just pull this surface, then it will increase from all the sides. Okay, so I have created these two and I say end tool. So these are extra extensions which I made. Now I have to make this one as a part of these two. So all these three are different STLs right now, but I have to join all of them. So again, I have to go to Boolean operations and I say I have to merge this one to 2. This is this. And I say apply. So this one has joined this. And now again, I have to join. I have to say geometry 2 here and here geometry 1. And then apply. So now this has become a part. Everything has become one part and I say end tool. Now I can rename it restoration with connector extensions. Okay. Now I have to connect the connectors. Here you see the connectors are now can extend to this. And this is anyways touching the process. So I go next. Now my base object is surgical guide. This is my base object and this restoration with connector guide is my removable object. So this is how it looks and I say apply. Prosthetics with connectors. Now I end tool here, finalize it. So I'll change my color here for the restoration, little yellowish white. So we have restoration with the connectors. And within the proper screw channel, if you see, the screw channels are perfect. And we have a restoration. So finally, patient gets this. Understood? I mean, until you practice, it's difficult, but then I hope I have cleared I have shown the possibilities in the software. So this is done. And save project, yes. Save project, yes. Okay. I'll go with bone reduction guide. So here in some situations, wish to reduce or trim the bone. And this is for open flap surgeries where you open the flap and your guide is resting on the bone. So this for that kind of guide. So I'll quickly go to guide design. Again, it is stackable. I am not making guide on the soft tissue. I'm making guide on the bone. So how did I get this bone here is bone segmentation on this step, which I have explained in my previous module. So I'll go here, select my path of insertion, and then block out as usual, and then go to next step. I am not involving in the first guide, I'm not involving the implants as I explained before, and I will switch on my pins. Of course, I extend my guide below the pins. Then I say create guide, smooth the surface. I go next. So my this is not a soft tissue guide, this is the bone guide. So just the base guide is ready. Now we go to sandbox. Here we will switch on I will switch off the implants. We'll switch on the mandible, the jaw. And again, as usual, I say bone splitting. Now here we want to decide how much of bone we want to trim. So I select apply, shift and hold, and I pull it down. Here as a doctor, you will decide how much bone you want to cut. So this, and also we switch on the surgical guide. So if you think you are fine and you are fine with cutting so much of bone, you want to trim off so much of bone in patient's mouth, then we go next. And here we have two still files. One is guide and one is bone. And I say subtract all slots and go next. So if you see, I have a bone which is cut, and this is how you will cut the bone in patient's mouth. And you have a guide like this, and you will place the pins, and you will stabilize the base guide. And now we need a surgical guide. Finalize it. I go create new guide again. Same steps what I have repeated in the previous stackable guide, but on different models. So now I click on this. Yes. So now I want to make a guide on the model which is cut. Now I have placed the base guide, I have cut the bone. Now I want to place a surgical guide. So click on this, path of insertion, generate undercut. Next. Now I don't need this pins in my guide. I need only implants in my guide. So I select through this. Yep. So I say create guide. I clean this. Next. So my surgical guide is partially ready. Again, I go to sandbox. As usual, we go to volume splitting. And then, as I said, I can adjust this a little. And then I go next. And I say split the object. So this is split and end tool. I finalize. So I don't need this residual below this. Click on this. So now I have I'll explain this case quickly. So I have a good jaw. I have a jaw like this. I make a surgical guide. Then I place pins. Then I trim off this excess bone in the patient's mouth. And then I have a guide with bone like this. Then I have surgical guide. like this, which fits very well on top of this, and then I place my implants. And as usual, how I showed how to add connectors, we go to sandbox and then add connectors like how I showed you previously, add connectors to these two up and down. It's a simple procedure. And then your stackable guides are bone reduction, bone supported stackable guide is ready. I'm not explaining connectors right now because we are out of time. So I'll exit this case here also. This is double scan. Double scan technique also I have explained in one of the previous modules. It's a complete edentulous case and we plan the case using radio markers. And after making planning with radio markers and everything, we will be using the denture itself as a guide. So this is possible only in double scan technique. So now when I click on guide design, it will ask me, do you want to use the prosthesis as your surgical guide? You say yes. And then here you have all the pins, and if you want to do stackable guide by cutting and everything, as usual, we can do that. I will not get into that. I will just say create guide. So it has created guide out of your denture scan, what we have done. We can, these are the radio markers which I have explained. The same case I had explained before. So I remove the radio markers if I don't need it and reduce all this. Whatever I don't need, I can just reduce it or I can cut it. I can write the name. And once I'm done, I can just go next step. And my surgical guide with the double scan is ready. I can also edit it if I need. I can go to edit datas and here and I click edit. If this scan is pretty neat, but it's not always like this. So we can go to area and we can cut off the extension which is not neat and clean. We can just cut it off, and then this we can give for printing. And orientation guide. So all these whatever guides we have spoken is for those who have Sky Pro guide surgical kit, those who want to do guided surgery with all the desktop and everything. But in some situations, if you don't have any Pro guide kit, you are freehand placing, but in some situations you want to use a guide. You will not be able to use exactly sleeve, but at least it will orient you the angle. So this is why this orientation guide I'm talking about. So I'll just explain only this particular situation. Now my path of insertion is like this, and I generate undercut. Implant is already planned. All the procedures are same, and go next. Now here I don't use sleeve because I'm not using guided kit. So I deselect this, but I mark my margin around it. And I say create guide, smooth the surface. Yeah. So now we have guide ready, but we don't have a space here to drill. So what I do is I I click on implants and the abutment. I try to see from the occlusal point of view as straight as possible. This is all visual because we are not using guided surgery. For those who don't have Pro Guide kit, surgical kit. And once I see from the top view, I create a round window. I increase the depth, the height of the round window, and then I try to reduce the window size or approximately window size somewhere around this. Yeah. Then I just click on top of this. So then I have a hole. So approximately without, if you don't have kit and you don't want sleeve, you can approximately make a window like this, and you can use this as a guide. This is not a complete surgical guide procedure, but yeah, this is for those who don't have kit. So I'm sorry, this is a long session because I had to explain too many things. And then the next, once we have designed the guide, we get guide like this with hexagonal shape. And once we print, we get sleeve of 4 mm and 6 mm height, and then we need to glue that into this. So generally how we practice is, as soon as the guide is printed, we place this into this slot by applying a little bit of resin, uncured resin on top of this. And the guide is just printed by placing uncured resin on top of this, and we place this into this, and then we cure it in curing box together, so the sleeve is tightly holding into the surgical guide and it is not disturbed during surgical procedure. So this is how we follow, but many of them also use cement to place it, but it's your choice. And we can either print it or mill it. In SkyPro Guide, we have an option called we can export guide and model, which we can print, and we can export guide for milling. So when you export guide for milling, it is exported in such a format that the coordinates are set so that you can place it in your blank so that you can mill. But if you're exporting as guide, you can just go for 3D printing. And for 3D printing, you can give flat surface like this, depending on your software. If it can produce supports only on the rim, then you can place it like this. If your software makes supports inside also, then I think you should place it something like this to the surface. So this is concave is up and convex is down, and this is how supports are formed. According to my experience, the flat surfaces, if this is a 3D printing table, you can print maximum 2 to 3 or 4 guides, and it's more accurate, and it will take around 20 to 45 minutes to print. But again, if you want to print too many, then you can also have 45 degrees or 90 degrees. But it takes more time. For surgical guide, it is okay. Accuracy is acceptable. But still, if you want more precise, I think flat surface works well. Otherwise, 45 degrees or 90 degrees, this is how 90 degree supports will come, which I don't like much because it gets into the sleeve area and all. But you can print many guides, like depending on the size of your plate, around 7 to 15 guides you can print at a time. So this is it for today. And if you have any questions, I'm here. Otherwise, I'm done for this session today. I know it's long, but I'm sorry, but yeah, that was required. Thank you.